Okay, let's look at this one. Show that the roots of the equation r+1 x squared minus 4x plus 1 is equal to r are real for all real values of r. Okay, so once again we need to write the equation in standard form. So obviously here we have an r that is on the other side. The x squared term has a coefficient expression of r+1. The x term has a coefficient of 4. Then when we transpose the r, we have the constant term, which has an expression of 1 minus r. So we identify a, b, and c. A is equal to r+1, b is equal to 4, and c is equal to 1 minus r. We take the a, b, and c, we write down delta, which is b squared minus 4ac. We substitute in the place of b the value of 4. Then we square it minus 4. In the place of a, we substitute the expression r+1 in brackets. And then in the place of c, we substitute the expression 1 minus r. Okay. Then after that, 4 squared is 16 minus 4. Now obviously this is a monomial with a binomial by a binomial. So what we do is that we FOIL out the binomial. R times 1 is r times negative r is negative r squared. 1 times 1 is 1, positive 1. And 1 times negative r gives you negative r. Then we take the negative 4, which was awaiting the distribution. Okay, we first add the like terms there. R minus r gives you 0. Then negative r plus 1 is left behind inside the bracket, whereby you can take the negative 4, distribute it into the negative r. A negative times a negative gives you a positive. 4 times r is 4r squared. Then a negative times another positive gives you a negative. 4 times 1 is 4. Then you add the like terms. So we are left with 4r squared, which becomes the first term, followed by 16 minus 4, which is 12. Delta, okay, is giving a positive value. It will be greater than 0. And the reason why we say that is because substitute any value of r here. Okay, when it says for all real values of r, remember real numbers are all the rational and irrational numbers. Substitute any real number here. Okay, if you substitute in brackets, which is what you do when you substitute a particular real number, you will square it, it will become positive. Whether it's a positive number or a negative number, it will always be positive. You take that positive number, you multiply it by another positive number, it will give you something that is positive. Additionally, you add a positive number to what is already positive. It will ensure that indeed the value of delta is a positive value. That's why we make the solid conclusion that delta is greater than 0. Then we can conclude that the roots are indeed real, because when delta is greater than 0, we know that the roots are real. This is not a perfect square, all right? This here can be termed as a perfect square, 4r squared. In and of itself as an expression, it is a perfect square. But then you add a 12 to it, that may change the dynamics. So we can make the conclusion that indeed that the roots are real for all real values of r, okay, because of the fact that delta is greater than 0, and we know that what will be the situation if we were to substitute any value of r that's real. Okay, I hope that basically makes a lot of sense and helps you understand why it is that when we do show that type of questions, whether the condition is for real values or for non-real values, as long as we know what that means, we can always be able to make a deduction or a conclusion after being able to notify ourselves as to what delta is like as an expression.